when you set up models. So all of the M plus stuff, by the way, is in this one packet. So we're just going through it in order at this point. The model that we looked at just a little bit ago, example 2, where we're looking at negative mood predicting symptoms. Because I person means centered my negative mood predictor, I know everything at level 2 is between. So what I say in the syntax, whatever I do here is irrelevant. I set up the variables, and so I know what their meaning is. If I use person means centering to decompose an X variable into its level 2 and level 1 parts, the level 2 is between, the level 1 is within the end. If I don't do that, if I put in the original level 1 variable, or the level 1 variable centered at a constant, whatever, then I know everything at level 2 is contextual. Regardless of what else I say in the model, if I don't partition the variance myself, if level 1 is the original level 1 and that goes in the within model, everything in level 2 is contextual. All bets are off, though, when you let it partition things. And that's what we're switching to here in this current example, looking at mediation. So all of the level 1 effects that we're going to be looking at are contemporaneous. It's the same day. One could argue with me as to whether or not that makes any sense, and or these should be lagged. If you wanted to lag them, I have an example later on that looks at various ways to accomplish that. But for right now, these are contemporaneous effects within persons and then between persons over time. So we looked at the first model in which, because stress is binary, I can't let M plus partition its variance. I have to do it myself. And because stress is binary, I chose not to do it. So the original level 1 stress is 0, 1. I added person mean stress at level 2. So because the original level 1 variable is all of the variation in stress, I know that the level 2 terms are going to be contextual. So I end up with within effects and contextual effects. Within at level 1, contextual at 2. And this was where we left off. So any questions before we dive back in?
Just very briefly again, because it helps me hear it, talk about the difference in interpretation between the contextual effects with stated English versus looking at it.
Yes. So I'll do that using numbers. Is that okay? All right. So here's my output from my model. This right here is contextual. This is within. So the easy way to think of what contextual means is that the difference of 0.1 within and 1.4 between is this 1.3. The way that is more helpful to thinking about what it actually means is after controlling for whether or not I had a stressor today, after controlling for the level 1 predictor, what is the extra impact of the person mean? So after controlling for whether or not I had a stressor today, for every unit more stress I have on average, my average symptoms goes up by 1.3. Without controlling for whether or not I had a stressor today, for every unit more stress I have than other people, my average symptoms goes up by 1.4. So it's whether or not it's after controlling for whatever at level 1. After controlling for is contextual. Without controlling for is between. You can also think of this contextual effect as the verification that smushing is not acceptable. If I were to just put stress in the model and not have person mean stress with it, it would tell me that the within stress effect is 0.1, and the between stress effect is 0.1. So the contextual effect picks up the difference between what the smushed effect would say and what the between effect really is. You don't have to report contextual effects if you don't want to. You just have to know what the software is giving you so that you can overpower it. There's nothing that stops you from talking about your within effects and the between effect that you got from tricking M+ into giving it to you. You just have to know that you need to trick it. Okay, is that good? Okay. Others? Questions? All right, are you ready for your very first multivariate multi-level model? I know, right? Step 2. So first I wanted to see if stress predicted symptoms before controlling for my mediator. Likewise, I'd like to know if my mediator predicts symptoms before controlling for stress. Then we'll see if they both predict symptoms after controlling for the other. So I have the brute force version of the model over here on the left in SAS, where now negative mood is the predictor, symptoms is the outcome. And because SAS only lets you partition one variable at a time, I had to carve up negative mood. So this is not the same model. I'm letting M+ estimate the variance in mood along with the variance in symptoms over here instead. So here are the variables we're putting in the model. Symptoms is my level 1 outcome. Women is a level 2 predictor. Age 80 is a level 2 predictor. Mood 2 is time varying negative mood centered at 2, so that 0 means something. So even though I'm going to let M+ partition its variance, I still want 0 to mean something because it's a predictor. Those rules still apply. Last but not least, I have the level 2 interaction between age and gender, which is defined, was made and defined. So note what goes into the within statement. Now, nothing. Things that go in within are variables that are to be used only at level 1, and I don't have any. Things that go in between are variables that are to be used only at level 2, and those are just my level 2 covariates and their interaction. So by not writing mood or symptoms on within or between, that's telling M+ to figure out how much of them is within and between. Circles. Where's my picture? This one. This is what we're doing. Here's mood, here's symptoms. Circles for everything. So now, both mood and symptoms are part of the likelihood. That means they both have distributional assumptions of multivariate normal at each level. And their means, variances, and covariances are things that the model is trying to find. So here's symptoms listed by itself in the within model. That's my level 1 residual variance in symptoms. Likewise, mood 2 listed by itself is my level 1 residual variance in mood. The relationship between them at level 1, I have given a name of within person M to Y here, and I have symptoms on mood. So by putting this here, it is the within part of mood that is predicting the within part of symptoms, because these terms refer to these estimated variances right here. So in the picture, the circle predicts the circle. So that's what we're talking about right here, this purple path. Or in this, this path, before controlling for stress. Then at level 2 are all the fixed effects and any random effect variances. So in brackets, that's my fixed intercept for symptoms. Likewise, in brackets, that's my fixed intercept for mood. Symptoms listed by itself refers to its level 2 random intercept variance. Mood listed by itself refers to its level 2 random intercept variance. So now we've made these two circles, the green ones. The next section here, that is going to define my fixed and random effects for the level 1 placeholder. So the within person effect of negative mood predicting symptoms, that thing in brackets, that's its fixed effect. And I do not have a random variance for it. Whether or not I need one is an empirical question. I do not believe that I do based on previous analyses, so I left it out. But that's something that you would want to test using a likelihood ratio test, the same as we did yesterday. Here's a quiz. What would it look like if I wanted to estimate this random variance instead? Yep. And I got to do one more thing. If I'm going to have a random slope variance, what do I need to go with it? Covariance, yep. So I would also need to do this. So if I introduce the random slope variance for the within person effect of negative mood, I also need to give it a covariance with the random intercept. And
the intercept of mood?
That's right. Yep. So there would be, at this point, 3 different random effects. There would be random intercept symptoms, random intercept mood, random slope for the within person mood effect on symptoms.
Don't we need to correlate the intercepts?
That is what this is doing right here. Yep. So I'm regressing one on the other instead of correlating it, 6 of one, half dozen of the other. But yes, so this captures the remaining relationship that I would have here. And note what I've labeled it. Because I used a placeholder to define a level 1 relationship, my level 2 affective mood that goes with it is contextual. So to recap, I did not brute force partition mood. I let the model do it. It was happy to make me a residual variance and a random intercept variance. But by invoking this placeholder right here, it automatically, without my permission and with no other option, switches this level 2 relationship to be the contextual effect instead of the between. I'm going to remove this so that we don't get confused later, but this is what it would look like if you wanted to estimate the random variance and its covariances instead. There. So then we do get between person effects of gender and age and their interaction on symptoms. This one is contextual. To get back to the between, within plus contextual is between.
So that contextual effect is not obvious. You take you a while to figure that out.
Yes. I would not have known about this had I not made up the data myself and known what should have happened. And it was when I was actually writing chapter 9 that I figured all this stuff out, because I was playing around with the syntax and not getting the right answers and getting answers that seemed really, really wrong. And I was like, what is going on? And then I finally put it together that that's what it was, and I was so mad. It's like, why am I having to figure this out? Why didn't they tell me? So, and then I thought, wait a minute, job security. The jig is up. Yep, this is totally not obvious. And what we'll see in the afternoon example, if you do different versions of this, if you change it from no placeholder, like if you do this, just put it in level 1, do you know what happens? This switches back to between. Yep. So this is the same model, just listing the fixed effect in level 1 instead of at level 2. But invoking this placeholder thing forces it to become contextual instead. So I had a question over break, why am I doing it this way? In this particular model, this is a fine alternative. This would be fine. If I did it this way, I would not have any of this, and the level 1 fixed effect would be listed as part of the level 1 within model. However, if you want to have either a random slope for this variable at level 2 or a cross-level interaction with it, the only way to specify those is using this placeholder. And specifying the placeholder switches the effects to contextual for the variables that are part of that placeholder. Oh, yeah, see, I showed you. I thought I had done that. On the next page, I have a side-by-side comparison as to what you get.
Before you go on, can I ask a quick question?
Certainly.
We talked about convergence, but how does that look different in terms of the equation stuff?
Yeah, you'll note I punted on equations in this example. Multi-level, multivariate equations can be a bit of a headache. I have, in the example that we're doing later today that also involves a growth model, let me pull that up. It would look something like this, where you would have to use a couple of different ways of doing it. If you don't want to adopt some sort of additional like superscript that indicates which DV you're predicting, you can also indicate that with like a dummy code. So you would have a dummy code for which outcome you're predicting, as multiplying everything, and then you would list predictor or variable specific effects in it. But in these models, the U's would actually become predictors. So in chapter 9, I have an example of an equation for that where the U's are predicting each other. And it's not something that I ever see in papers. I had to sort of make up what it would look like. I find if you're going to have an equation, like a lot of times they do just a matrix version where everything's compact and you can't tell what's in it and it's not helpful. So if you're going to have an equation, you would have to write it out. Literally, it's like what does the equation look like that makes symptoms? What does the equation look like that makes mood? And then you would have to substitute in, because the random intercept for mood would predict the random intercept for symptoms. So I could probably work up an example like over lunch and show you, but I don't think I could do it quickly enough for our purposes in front of you. I'd be happy to do that. Other questions? So yeah, I have this version of the model that uses the placeholder, and on the next page, I have its output over here in the left-hand column. And then the same model without the placeholder, where the level 1 effect is defined in level 1. And I have them side by side so you can see how the effects are different. So if we start on the left-hand column, the terms that are underlined are the extra terms that are being estimated when you let M plus partition the variance for your time varying predictor relative to when you brute force partition it. When the time varying predictor becomes part of the likelihood when its variances are getting found, you pick up a residual variance at level 1 for it, the 0.09 here. You pick up a random intercept for it, its variance at level 2, the 0.05, and you pick up its mean, right here. So this is the fixed intercept for the mood predictor. So this will be 0 when it is a value of 2. The actual mean is not quite 2, as you can see. So let's see the things that are the same. The residual variance at level 1 in symptoms is the same. It should be, it's the same model. The level 1 residual variance in mood, the predictor, is the same. It should be, it's the same model. Note the difference in the labels. Why is mood 2 a variance, but symptoms is a residual variance? Any guesses? Yep, symptoms is being predicted. So residual to it means left over. Mood is not being predicted, so it's just a variance. Even though I would call these both level 1 residual variances because they're within terms. Likewise, the effects of age, gender, and their interaction predicting the symptoms intercept are the same across models because age and gender are purely level 2. Therefore, they can only be there between effects. There's nothing to contextual them. There's no analog at level 1, so you don't have to worry about what those mean. Those are between, and they're the same. Likewise, the fixed intercept is the same for symptoms because it's the same model, and the random intercept variance is the same. Again, labeled residual variance because it's random intercept left over after controlling for between person mood. And now the difference is then in what you get and where it shows up. So on the left, the level 1 effect of within person negative mood predicting symptoms, WPM to Y, shows up in the between model, and it is labeled as a mean. This is its fixed effect, 1.167. That's because we used a placeholder named WPM to Y, and then we put its fixed effect as part of level 2, so on the output, it shows up as part of the level 2 between. The same model, statistically equivalent model, specified differently with syntax, puts the level 1 effect in the within level when you don't use a placeholder and you just put the on there in level 1. So it shows up over here instead, but it's the same. So it's still just a fixed effect at level 1. Now the big difference is what happens at level 2. The level 2 variable is the same. Mood 2 on symptoms is the regression between the random intercept for negative mood as a predictor, predicting the random intercept of symptoms, the outcome. However, the coefficient you get is different because they mean different things. Given the use of the level 1 placeholder on the left, 2.3 is the contextual effect. Without the level 1 placeholder on the right, 2.5 is the between effect. So the 2.5 means, without controlling for how grumpy I am today, for every unit grumpier I am than other people on average, I get 2.5 more symptoms on average. For every unit grumpier I am than other people on average, I get 2.5 more symptoms on average. After controlling for how grumpy I am today, I only get 2.3 more symptoms on average. So the within effect is the 0.17. Within plus the contextual of 2.3 gets us the between that is 2.5. That's on the left-hand side. On the right-hand side, if what you have is within at level 1 and between at level 2, the difference is contextual, and that's what I asked for to show that it's the same within rounding error, as you can tell. How are we doing? Stretching. Yeah. Are you with me? Are you irritated with the mutanes yet? I'm just being ungrateful. I'm like, I let you do all of this syntax, and it doesn't even take very many words to type it out, and that's not enough for you. So yes, when you let the model partition your variance in a predictor, if you invoke the placeholder at level 1, you get contextual effects at level 2. If you do not invoke the placeholder at level 1, you get between effects at level 2. last model here in the mediation sequence. Oh, no question? Yes, sir.
So does that mean in the right-hand results, the M plus is going person mean centering at level 1 when you put in it?
It's not person mean centering by brute force, but yes, when it makes the variance for you, it is analogous to person mean centering because you get level 1 residual that's purely within and level 2 random that's purely between. That is the case for either side of the model. It's just what the regression means between those variance components changes at level 2 based on how you set up level 1. Other questions? So the grand finale of mediation here, putting it all together and adding indirect effects. So I will point out in terms of my within person effects previously, this is not significant. So this still does not bode well for within person mediation. However, the between and the contextual effects from M to Y are significant. So we still have a shot at between person here. So here's what I'm doing is combining the two models where I have stress predicting symptoms and mood predicting symptoms. And for comparable interpretation of stress predicting mood, I added effects of age and sex on that as well. So in this model here labeled step 3, stress goes on the within line because that is still an observed variable. That's my binary 0-1 variable. I have unsmushed its effect by adding person mean stress at level 2, and I had to do it through brute force because stress is binary. But neither mood nor symptoms are listed on within or between, which means they're going to get their variances found by the model. So now at the within level, I have residual variance in symptoms, I have residual variance in mood. I do not have residual variance in stress. Stress is not part of the likelihood, only its fixed effects are. I have all 3 fixed effects for my mediation triangle, X to M, X to Y, and M to Y. I have, in the between level, my fixed intercept for symptoms, random intercept variance for symptoms, fixed intercept for mood, random intercept variance for mood, and then the series of fixed and random effects for the level 1 part of the model. Again, no random effects here. You could test whether or not you need them, and you probably should. These are all within effects, within person. Then we get into the between part of the model. So I am predicting both symptoms and mood by gender, age, and their interaction. And then I get to the level 2 part of the mediation triangle. So X to M is first. That's observed person mean stress predicting the random intercept variance for mood. X to Y is the observed person mean stress predicting the random intercept variance for symptoms. And M to Y is the random intercept variance for mood predicting the random intercept variance for symptoms. And as you may note by the labels I'm choosing, all 3 of these things are contextual effects. That means to get to the betweens, I've got to add each of their within effects to their contextuals. So that's in model constraint here. So I get the between version of each of those first. And now I can make my indirect effect. So brief tutorial on the logic of mediation, going back to the picture here. The question as to whether the effect of x on y, x to y, excuse me, is different after controlling for your mediator, that question is answered by what's called the indirect effect, which is this path from x to m multiplied by this path from m to y. But because I have two sets of these, I've got two possible indirect effects. In single level models, there is a model indirect command that you can use to get indirect effects and total indirect effects and all that stuff. You can't do that in multi-level models, but you can make it do the math. So here's my within person indirect effect. It's the x to m path times the m to y path at level 1. I have a contextual indirect effect, is what's given to me by the two level 2 effects that show up in the model, and then the between person version, which uses the between effects that I just made. And I have a note here about yet another thing that I can't bring myself to care about, but someone's going to yell at you. These p-values that you're going to get here are wrong. You need to bootstrap something. Unfortunately, you can't turn on bootstrapping in multi-level models, so you may have to bootstrap the parameter estimates. And I refer you to Chris Preacher's website for little modules that you can plug numbers into and get the right version. I say I can't possibly care about this because in practice, I have never seen this matter. But someone's going to yell at you. So, Reviewer 3 is going to demand bootstrap confidence intervals and p-values for your indirect effects, and you better give it to them. All right, so questions on the syntax, putting this all together. Could I have done this in another program like SAS or Stata Mixed or LMER? Nope. Why are you shaking your head? You're correct.
The program is partitioning the variance and then you have
Yep, because the program is partitioning the variance in mood, and mood is both an outcome and a predictor. I did see a paper once where someone tricked SAS into doing this for a within-person mediation model only, but they couldn't get the between estimated at the same time. So to me, I don't know why you would ignore one and focus on the other, but you can trick SAS into it if you're interested only in within by using person mean-centered versions of the variables and some programming. But here we go. So on the left side here, so the within level doesn't have any fixed effects. It has just the leftover variance in mood and the leftover variance in symptoms at level 1. I have the covariate effects here first for symptoms. It looks like there is a significant contextual effect of stress on symptoms and mood on symptoms. There is not a significant contextual effect of stress predicting mood. Here are my within-person fixed effects. Here are the fixed intercepts for mood and symptoms. None of my within-person effects are random. Had they been random, I would have had to have computed my indirect effects differently. I can tell you more about that if anyone cares. These are the leftover random intercept variances in mood and symptoms. And then last but not least, our between effects and our indirect effects. So the between effects then are the level 2 effects not controlling for level 1. The indirect effects are the x to m times m to y coefficients. And these are the p-values that someone's going to yell at you about. But I'm guessing bootstrapping isn't going to change the story here. There is not a significant within-person effect. So the relationship between stress and symptoms did not change after controlling for mood. There is a significant indirect effect between persons, which means the relationship between having more stress than usual, or having more stress than other people, predicting feeling worse than other people, is different after you control for person differences in negative mood. However, the indirect effect appears to not be significant after controlling for the level 1 observations. So this is one case in which it matters what you're talking about here, contextual versus between. And I do have some words, because different is not very useful as an explanation. So this is what if I were reporting this is what I would focus on, is what were the effects before controlling for the other variable and how did they change? So for instance, if I pick out a few sentences here to illustrate, the between-person effect of stressors on physical symptoms X to Y was significantly reduced from 1.4 to 1.1 after controlling for between-person negative mood. I know that those numbers are different because of the significant between-person indirect effect. The other way of saying that would be to focus on the M to Y relationship and how that changed. It went from 2.5 to 1.8 after controlling for stressors. And so we would talk about what happened between and what happened within as well. Within, there's not much to say. So in this story, all of the mediation was between persons, none of it was within. And if we, yeah, go ahead.
But if all of it was between, none of it was within, does that still then imply that there was no benefit to testing it over time? Or for doing it longitudinal?
Yep. Yeah, basically you wasted your time. This could have been a cross-sectional study, and unless you want to argue the null is meaningful. If you want to make that your story, then that's a different thing. But yeah, yep. But too often I've also seen people smush mediation models. There should be 2 levels of analysis here for each variable that has 2 levels of variance, and that means there's 2 different indirect effects. Okay. Other questions on that mediation model? All right, so let me show you what this looks like then if I were to try and add interaction terms, because that's also different when you let the model partition the variance in a predictor if you want that predictor to interact with other things. So first, I tried to estimate the same model, adding just an interaction term between mood and gender as a latent variable interaction, and I got yelled at. It insisted that it would be an observed variable, but I didn't want that. I wanted the level 2 part to interact with stress. So this is a trick that I found on an M+ discussion board that Linda Butane suggested when you get this particular error that you can't do something. So things that are different. In order to let it create an interaction of between person mood by gender, I have to functionally rename the random intercept for between person mood. It's a trick. That happens right here. So I am defining what M+ thinks is a latent variable. I am calling it mood int, which stands for mood intercept. However, I am defining it with a measurement model that consists of my mood actual random intercept, where the @1 means that it loads perfectly. I have then shut off the fixed intercept from the original variable, as well as its intercept variance, and turned on the fixed intercept for my new latent variable, and turned on its variance as well. So in English, I have renamed it. I took mood 2, made M plus think it died, and made it rise again from the ashes as mood int. Why? I don't know why this is necessary, but when the mutate said it would work, and it did. So now everywhere that mood 2 used to be is mood int. It doesn't change any of the contextual effects. All of that stuff is still the same as before. But what it does allow me to now do is to put an interaction term with gender. So there's 2 interaction terms being added here. This is for sake of illustration. I am adding first whether or not the M to Y path differs between men and women. That's a cross-level interaction. I can do that using the placeholder for the within-person effect that I created earlier. If I want the analogous effect at level 2, I need the xwidth option right here. Xwidth defines a latent variable interaction. So even though women is an observed predictor, because mood int is a random intercept variance, it's considered latent, their interaction is latent. And this is the thing that regular mood couldn't do, but by renaming it as mood int, M plus is fine with it. And I then take that mood sex new interaction term that I've created and make it a predictor of symptoms. Clear as mud. So any of that you want to hear again? So yeah, renamed level 2 mood so that I could have it interact with gender. So I'm asking, does the extent to which being grumpier make you feel sicker than usual? Does the extent to which that matters differ between men and women? As well as the extent to which feeling grumpier than usual makes you feel worse than usual? Does that differ between men and women? And because this is going to be the contextual effect, I'm getting the between effect by adding the interaction terms back together. And I have the 2 new effects here highlighted in the output. So no, the within-person effect does not differ significantly between men and women. The contextual effect does not differ significantly between men and women. And the between effect doesn't either. Note that I have this a few minutes later. All of these previous models ran in a split second, and this one took a few minutes because this one has a latent variable interaction that requires numeric integration. Every additional term that you add is going to add another dimension to it such that it becomes exponentially more complicated. In practice, I've never seen more than like 2 interactions be estimable at the same time in real data. Okay. Questions? Anybody have data they want to play with that you do this kind of thing that you want to talk about? Free consulting help? I charge extra for significant results though.
I have a question.
there's a time one for everyone. And there could possibly be time two or not, time three or not, time four, time five or not. And the time one for everyone is at different calendar days. Some people might have time one in October and some people might have time one yesterday.
Okay.
So would that be unbalanced?
Yes, yes. So if people have time one at different times, that creates unbalanced data, yes.
Unless they were all the same chronological age at that point.
Then I think it depends on how you're setting up the model. So is time one, if the first occasion is the 0, no matter when it was, and then you keep track of how long it's been since then, if people have different intervals between the next set of occasions, it's unbalanced.
Because I was thinking it doesn't really matter if their first experience with this is October or yesterday, time one is time one for them. But because their intervals are different, that's what makes it unbalanced.
The difference in when the first time is going to create differences in when the next ones are between people, unless you kept it exactly the same. So like if time one was 2 months later, was time two also 2 months later? Like was it? Okay, then yeah, it's unbalanced. Whether or not what you just said is appropriate is actually an empirical question. So what I would do in that case is you could put in, treat time one as if it were balanced and fit whatever model you have, and then put in a covariate for how far off each person's time one value was relative to some average. And so then you could fit a slope for whether it actually matters how late or early your time one was as an additional effect. So I had an example of that in chapter 10 in the second example for the 3-level data. It was supposed to be every 6 months, but it didn't work out quite that way. And so I fit in a time metric in which it was exactly 6 months, and then I put in what I called an offset, like how early or late you were, and saw if that mattered additionally, and it didn't. And so I said, okay, well, it's balanced enough. But that's the kind of support that I would use for that, to see if it really does matter. Other questions? Things you want to chat about with respect to this or otherwise? Yes.
So all of this data is all
It's all what? I'm sorry?
it's all contemporaneous, it's all
Contemporaneous, yes.
Is it possible to do this type of mediation with like time 1 to time 2 to 3?
Yes and no. So are you talking about, let me get lecture 3. Are you talking about a picture that looks like this? Where X is time 1, predicts mediator at time 2?
Yeah.
So, no. I mean, you can do it, it would be wrong. These are all smushed. So you would have to, in order to do that properly, you would want to distinguish all of the between-person sources of variance. And then there's nothing that stops you from, within persons, having the mediation path take time. So, like in the picture here, once you control for between-person differences, then you don't have to worry about smushing. You could have stress on day 1 predict the next day's negative mood, which predicts the next day's physical symptoms, if you wanted to. And some would argue that that makes more sense theoretically because mediation should take time to unfold. But logically speaking, constant person differences that operate on all the days should not be part of time 1 predicting time 2 predicting time 3.
So how would you control it? Just
Having
having it
it at level 2 in a multi-level model so that you're splitting the variance by the model, or as a structural equation model I don't think I threw a picture in, but I have, that's the rest of this is fitting the same model as an SEM, in which you're using latent variables to represent these intercepts instead. Other questions? Okay.
Are you gonna cover time varying predictors? Predicting time varying predictors?
Oh, that's what these are. Do you mean time varying predictors that change? No, not necessarily. So so the example 2 that we did yesterday and then finished up today looking at negative mood and glucose, those are both time varying variables where we have a level 1 relationship within persons and a level 2 relationship between persons. When you are using univariate software, you are carving up one of them into boxes by brute force and letting the model do the other. We're just switching to letting the model carve up both of these things, but it's still the same idea as the level 1 versus the level 2 relationship between these variables. I still had to carve up stressors because it was binary. However, this is going to be insufficient when you have variables that have individual differences in change or in any other kind of random effect. So these paths down here, these are fixed effects. They could be random, right? Sure they could. If they were random, that would actually make another circle up here that you can think of as a predictor or outcome as other things. And if the X to M path is random and the M to Y path is random, then the indirect effect is random. So mediation could actually be person specific. People could vary in the size of their indirect effects. If that is the case, then the formula to compute the indirect effect right here, it has to add the covariance between the two random slopes as part of the indirect effect. So there's, I think you guys had Niall and his people here a couple of years ago. Yep, in that book, they talk about that, and there's an example where they add it. Although in their example, they're doing person mean centering for everything instead of letting the model partition it, but it would be the same. The expected value for the indirect effect needs to include the covariance when the two paths are likely to be related, which is what the covariance between the random slopes would mean. So yeah, even though this model is relatively complex, it's actually not from the perspective of all the things that could be in here. And whether or not they're needed, always likelihood ratio tests to figure that out.
One more question.
Yeah.
So if your stress variable were a continuous variable, normally distributed, can you trick in plus and be using an all-y model and partition now your ID stress?
If stress were normally distributed, I could include it let M plus partition it the same way as in stress and mood. As it turns out, I can trick it into partitioning it if I move over to the SEM side. So we haven't talked about the SEM side yet. I can do that if folks are interested. But yeah, I was able to, by transitioning this into a single level structural equation model, I was able to fit a latent factor that defines the stress intercept rather than put a box in. Do you guys want to see that? You don't have to. If the answer is no, you can say that. The intersection of multi-level and SEM I find is very confusing, and so I wanted to make sure that I covered like things both ways. And I could certainly talk about like why you would care to do it this way and when you wouldn't. But yeah, as it turns out, I was able to do latent partitioning of stress on the SEM side, just not on the MLM side.
I think that would be helpful to explain why we would, not necessarily how.
Why but not how? Yeah. I have a slide for that. So we haven't gotten very far into this lecture, but I have a slide for that. Okay, so slide 40 is summarizing what I was telling you before about what you get when, in terms of the placeholders and whatnot. But right after that is the why you would use each. So lecture 3, slide 41 is where I am. So yes, when would you do each if you can get the same model both ways? What I just showed you, the between, within side of M+, is easier when you have unbalanced data. It may be your only option if you have a lot of occasions. So as an example, my colleague Chris, he has 80 observations total for each person, 4 a day for 20 days, and he has 25 people. Do you think an 80 by 80 covariance matrix estimated on 25 people is going to go well? Nope. At a minimum, you should have like 1 person per covariance, don't you think? At a minimum. So yeah, if he tried to fit any of this stuff using SEM, the data structure is such that he would have to have 80 variables, and it would be working with an 80 by 80 covariance matrix, and it's not going to work. Whereas he can think of it as a 3-level model, where he has 25 people for level 3, he would have 25 people times 20 days for level 2, and 4 occasions by 20 days by 25 people for level 1. So if you have a lot of occasions, and if those occasions are unbalanced, SEM is not for you. The idea of building contemporaneous relationships, I think, is more straightforward on the MLM side, because you have the same variables in the same row. So you have a level 1 association, say, between X and Y, and it doesn't really matter how what's going on the other rows. You can define a contemporaneous relationship. Whereas on the SEM side, each occasion is a box. And so you can define contemporaneous relationships, but you have to keep in mind how far apart the boxes are and constrain the paths to mimic that spacing. So if you have, say, if you want X and Y to predict each other when measured at the same occasion, that's just Y on X in multivariate syntax. Whereas if you have, say, occasion 1, occasion 2, occasion 6, you might want to have, let me back up. I'm going down the wrong path here. I'm thinking of it in terms of cross-lagged. So that's when the SEM side actually becomes more advantageous. So in the MLM side, the between within side, it doesn't have access to your other rows. So that means if you want to have yesterday's X predict tomorrow's Y, you have to lag your data so that the 2 variables are on the same row. I have an example of that coming up later. On the SEM side, all of the variables are sitting in the model at the same time, and so you have access to all of them. So you can incorporate things like residual covariances, lagged effects, and you have all of that available to you. Whether or not you're using measurement models, that's either one. You can fit latent variable measurement models on the MLM side or the SEM side as well. So that shouldn't be a consideration. I think it really boils down to sample size of their occasions and their unbalance. If you have a lot of occasions and or they're really unbalanced, I think the MLM side is going to work better for you in most cases. So, yeah. I think I just said all that. But I wrote it down in case I forgot something, so. Another wrinkle in all of this is that some of the new features of M+ that allow these sorts of lagged relationships within the MLM side insist that you switch your estimator to be able to take advantage of them. It changes it from maximum likelihood to MCMC, Bayesian estimation. And although you can just say estimator equals Bayes and it will happily run, you're actually making a lot of choices that are default when you do that. And there's been some recent work suggesting that those choices should not be taken lightly, particularly for small samples, the influence of prior distributions and whatnot. So it's not quite as easy as I think they would want it to be, that you can just say, make it Bayes and it's fine. So for that reason, I don't have a whole lot on that because I don't have time to talk about Bayes. So it's an active area of research. I get the sense that we're sort of like winding down in our energy level. Is that perceptive?
This is a bit unrelated, but what is the most introductory introduction you can think of for Bayes? Like if you know nothing about it. I know that that's not the topic of this.
Yeah.
Since we're winding down.
So it's funny you should ask that. I lead a study group with my colleagues, and that's actually our topic that we're trying to read about right now is Bayes, particularly in the context of multi-level, and I have not found much that has been helpful. A lot of the Bayes books are talking about coin flips or things that are just like not relatable necessarily. And I started reading David Kaplan's book, and that one seems to be a little bit more realistic in terms of data. So that one might be a good one to try. There are a lot of how to use Bayes kinds of tutorials. So I would look maybe in, I think there was a special issue of Psych Methods fairly recently that had Bayes things, and you can find articles every now and again that talk about Bayes. I think the trick is trying to get away from the dogmatism of what it means theoretically versus what it means like in terms of how to do it. So whether you switch to Bayes because you just want to estimate something and ML won't work, or whether you switch to Bayes because you're like theoretically that's more appealing to you, a lot of the articles focus on the latter rather than like the nuts and bolts of what you would pick. So I don't have a great answer. I can, if you want, I can show you the articles that I've collected and maybe send them to you via email or something, if that would be helpful. But Bayes does not fix everything, contrary to what you may have heard. It is not a magic button. So, are we winding down? Do we need some food? Do we need a break? Yeah, they're getting it ready. I don't want to like make everyone stampede over while folks are still setting up, but how about we adjourn since the energy level is down, and we'll come back maybe like 1-ish. Would that work? Okay, all right. You can feel free to bother me during lunch. I'm just going to sit here. I don't have the headspace to do much of anything that's productive, so I'll just sit here and stare off into space, and if you want to come talk to me, you can. So, see you at 1.